Rithmomachia, the battle of numbers. Welcome. This tutorial explains how the piece values relate to each other in a clever way. Initial setup. 4 ranks per side. White at the bottom. Rank A to rank D. With territory A through H. Black is at the top, rank M to rank P, with territory I through P. In a moment, we'll show how the inventive monks arranged the pieces to that all the piece values derive from. Only 4 of them. First, let's look at some clever patterns showing how circles are related to the nearest triangle pieces. Add the 2 end circles to get the value of the neighboring triangle. 8 plus 64 equals 72 and 2 plus 4 equals 6. Likewise, for the black counterparts. 9 plus 81 equals 90 and 3 plus 9 equals 12. Amazing coincidence. We're just getting started. Add the 2 interior circles to get the value of the neighboring triangle. 6 plus 36 equals 42 and 4 plus 16 equals 20. Likewise, for the black counterparts, 5 plus 25 equals 30 and 7 plus 49 equals 56. You're saying to yourself, the medieval monks who invented this game figured out a nice arrangement of the circles and triangles. Big deal. No way that ingenious pattern can go on. Oh ye of little faith, just watch what's next. Add the 2 end triangles to get the value of the neighboring square. 72 plus 81 equals 153 and 6 plus 9 equals 15. Likewise, for the black counterparts, 12 plus 16 equals 28 and 90 plus 100 equals 190. Add the 2 interior triangles to get the value of the neighboring square. 42 plus 49 equals 91 and 20 plus 25 equals 45. Likewise, for the black counterparts, 30 plus 36 equals 66 and 56 plus 64 equals 120. We've seen how circles are related to nearby triangles pieces, and how triangles are related to nearby squares. This is a helpful check when you are setting up the pieces to play. Next, we'll show how to use only the 4 lowest valued circles to get all the other values. For each of these highlighted pieces, square them to get the next pieces. For each of these highlighted pieces, shift the value by 1, then square this closely related number. First, v equals 3, so v plus 1 equals 4, so v plus 1 squared equals 16. Next v equals 5, so v plus 1 equals 6, so v plus 1 squared equals 36. And so on. First, v equals 2, so v plus 1 equals 3, so v plus 1 squared equals 9. Next v equals 4, so v plus 1 equals 5, so v plus 1 squared equals 25. And so on. For each of these highlighted pieces, double the value and shift by 1, then square this closely related number. v equals 3, so 2v plus 1 equals 7, so 2v plus 1 squared equals 49. Next v equals 5, so 2v plus 1 equals 11, so 2v plus 1 squared equals 121. And so on. v equals 2, so 2v plus 1 equals 5, so 2v plus 1 squared equals 25. next v equals 4, so 2v plus 1 equals 9, so 2v plus 1 squared equals 81, and so on. These are all the square-valued pieces derived from those basic circle pieces. How do these basic circle pieces generate the remaining pieces? In addition to the squared values, like v squared, nearby numbers of the form v times v plus 1 are also used. Also known as rectangular numbers, the numbers v times v plus 1 tell you the sum of all the even integers up to 2v. The Greeks knew this cool formula. V equals 3, so v plus 1 equals 4, so v times versus plus 1 equals 12. Next v equals 5, so v plus 1 equals 6, so v times versus plus 1 equals 30, and so on. V equals 2, so v plus 1 equals 3, so v times versus plus 1 equals 6. Next v equals 4, so v plus 1 equals 5, so v times versus plus 1 equals 20, and so on. We aren't done with the use of these unusual number sequences. Take all the squares up to v. Add them up and multiply by 6. You get v plus 1. 2v plus 1. The Greeks knew this formula. 2. V equals 3, so versus plus 1 times 2v plus 1 equals 28. Next v equals 5, so versus plus 1 times 2v plus 1 equals 66, and so on. V equals 2, so versus plus 1 times 2v plus 1 equals 15. Next v equals 4, so versus plus 1 times 2v plus 1 equals 45, and so on. It's amazing that this was all worked out over 1,000 years ago, isn't it? The values of the basic circles generate all the other values by these classically known constructions. Thanks for watching this video about piece values in rithmomachia.